Hey guys and girls, this is me Saima Parveen. Today we are going to learn about empirical formula and molecular formula. Let's start with the empirical formula. It is a formula which is found by experiment. It represents the simplest ratio but not the actual number of the combining atoms in a molecule. For example, the empirical formula of benzene C6H6 is CH. Some compounds can have same empirical as well as molecular formulas. For example, carbon dioxide and water because they are in simplest ratio, so they cannot be more simplified. Here are a few steps for determination of empirical formula. First is the detection of elements in compound, which is almost done by an experiment. Second is the determination of masses of elements, calculation of percentage of elements, calculation of mole ratio, and at last calculation of simplest ratio, which is actually the empirical formula. Taking an example, here we have a question through which we will find the empirical formula. 1.367 gram of an organic compound containing carbon, hydrogen and oxygen was combusted in a stream of air to yield 3.002 gram of carbon dioxide and 1.640 gram of water. What is its empirical formula? So first of all, we need to set out the data. Sample mass is equals to 1.367 gram. Mass of carbon dioxide is 3.002 gram. Mass of water is 1.640 gram. Empirical formula we need to find out. Therefore, moving towards the solution. By following steps, the first step is mass of element, which can be calculated by the given formula, that is mass of given element multiplied by mass given mass of compound divided by molar mass of compound. So here we need to find out the mass of carbon because the elements we have present in our question were carbon, hydrogen and oxygen. So we will calculate the mass of each element. The mass of carbon can be found out by the given formula, that is mass of carbon is equals to mass of carbon in carbon dioxide multiplied by mass of carbon dioxide divided by molar mass of carbon dioxide. Here we have the values. By calculating, we will get the mass of carbon, that is 0.818 gram. Therefore, moving towards the mass of hydrogen, mass of hydrogen is equals to the mass of hydrogen in water, which is 2, and multiplied by given mass of water divided by molar mass of water. By putting values from the data, you can calculate the mass of hydrogen, which is 0.182 gram. Therefore, we will move towards the next step, which is percentage of element. We are not finding out here the mass of oxygen because oxygen is present in both of the compounds, which is water and carbon dioxide. So we will directly calculate the percentage of oxygen in next step. So the percentage of element can be calculated by the mass of element divided by sample mass multiplied by 100. So here we calculate the mass of carbon, percentage of carbon. Percentage of carbon is equals to mass of carbon divided by sample mass multiplied by 100. Sample mass is present in the data. By putting values, we can calculate the percentage of carbon, that is 59.83%. Therefore, moving towards the percentage of hydrogen. Percentage of hydrogen can be calculated by the mass of hydrogen divided by sample mass multiplied by 100. By putting values, you can get the percentage of hydrogen, that is 11.09%. Now, moving towards the calculation of percentage of oxygen. The percentage of oxygen can be calculated by the given formula, that is 100 minus percentage of carbon and percentage of hydrogen. So first we need to add the percentage of carbon and percentage of hydrogen, then subtract it from 100. We will get the percentage of oxygen, that is 29.47%. Now moving towards the third step, which is the mole ratio. Mole ratio is equals to the percentage of element divided by atomic mass. So now we need to calculate the mole ratio of carbon. Therefore, percentage of carbon and their atomic mass is divided. Then by putting values, we will calculate the mole ratio of carbon, which is equal to 4.98. Now mole ratio of hydrogen, which is calculated by dividing the percentage of hydrogen divided by its atomic mass. Then we get the mole ratio of hydrogen, that is 11.09. Now the mole ratio of oxygen, percentage of oxygen divided by the atomic mass, we will get the mole ratio of oxygen, that is 1.84. Now moving towards the last step, the simplest ratio. Simplest ratio is equal to the mole ratio divided by smallest mole ratio. So we need to find out the smallest mole ratio. For finding out the simplest ratio of carbon, the formula used is mole ratio of carbon divided by smallest mole ratio. The mole ratio of carbon is 4.98. So we divide it with the smallest mole ratio, which is 1.84. We will get the simplest mole ratio of carbon. The mole ratio of hydrogen can be found out by mole ratio of hydrogen divided by smallest mole ratio. The mole ratio of hydrogen is 11.09, which is divided by 1.84. Then we get the simplest mole ratio of hydrogen. Simplest ratio of hydrogen, that is 6. Now mole ratio of oxygen, which is actually the smallest mole ratio. So we divide the mole ratio of oxygen 1.84 with the 1.84. We will get 1 simplest ratio of oxygen. Now here you can see the simplest ratio of carbon is 2.71, but we round it off, but it is rounded off to 3. How we use the rules of rounding of data we will discuss later. Now we take the values of simplest ratio of each element and write down the empirical formula. Therefore, the empirical formula of the unknown compound will be C3H6O. This is how we can find out the empirical formula of any compound. Now moving towards the molecular formula. Molecular formula is actually a formula that expresses not only the relative number of atoms of each element, but also the actual number of atoms of each element in one molecule of a compound. The molecular formula is the integral multiple of empirical formula. Here we have few steps for determination of molecular formula. First, we determine the value of n, that the number by which we multiply the empirical formula. Second step is the calculation of molecular formula. Now taking an example. Here we have a question. Acetic acid contains carbon, hydrogen and oxygen. 4.24 gram of sample mass of acetic acid on combustion gave 6.21 gram of carbon dioxide and 2.54 gram of water. The molecular mass of acetic acid is also given, which is 60. Find empirical formula of acetic acid and molecular formula of acetic acid. Now, as we done previously, first set out the data. Here we have sample mass 4.24 gram, mass of carbon dioxide 6.21 gram, mass of water 2.54 gram. Molecular mass of sample is 60 atomic mass unit. Empirical formula is equals to question mark and molecular formula is equals to question mark. So first we need to find out the empirical formula as we have done previously. So moving towards the first step, which is mass of element. We will find the mass of carbon by putting values from the data. We can calculate the mass of carbon, that is 1.69 gram. Therefore, mass of hydrogen. By putting values from the data, we will calculate the mass of hydrogen, that is 0.28 gram. Now, same as previously, we will calculate the percentage of oxygen in the next step and do not calculate the mass of oxygen because oxygen is present in both the compounds. Now moving towards the second step, the percentage of element. We need to find out the percentage of carbon, so we will put the values and we will get the percentage of carbon, that is 39.8%. Therefore, moving towards the percentage of hydrogen, and by putting values we will calculate the percentage of hydrogen, that is 6.6%. And last we will calculate the percentage of oxygen by subtracting the percentage of carbon and percentage of oxygen from 100. We will get the percentage of oxygen, that is 53.6%. Now moving towards the next step, mole ratio. Mole ratio of carbon can be calculated by putting values. We will get the mole ratio of carbon, that is 3.31, and secondly the mole ratio of hydrogen. By putting values we will get 6.6, and the mole ratio of oxygen we will get by putting values is 3.35. Moving towards last step of the empirical formula, that is simplest ratio. We can calculate simplest ratio of carbon by putting values. We will get the simplest ratio of carbon, that is 1. Similarly, the simplest ratio of hydrogen is 1.99 and it is rounded off to 2. Simplest ratio of oxygen is 1.01, that is rounded off to 1. You can write the empirical formula as follows: C1H2O. Now moving towards the molecular formula. So for finding out the molecular formula, we need to find out the value of N. N can be found out by molecular mass divided by empirical formula mass. Molecular mass is given in the data, and empirical formula mass you can calculate from the empirical formula which we had find previously. Therefore, by dividing molecular mass and empirical formula mass, we will get the value of N, that is 2. Moving towards the last step, molecular formula is equals to empirical formula multiplied by N. Here we have our empirical formula, multiply it by 2. When C is multiplied by 2, we get C2. When H is multiplied by 2, we will get 4 because 2 multiplied by 2 is equals to 4. And when oxygen is multiplied by 2, we will get 2. So the molecular formula will be C2H4O2. Here are few questions for your practice. You can solve it by yourself. Similarly, as we have calculated by using all the formulas. And in next lecture, we will discuss about the rounding of data, that how we can use the rules of rounding of data. Thank you.